is video B for section 3.3. Let's go on to this problem. We want to find the derivative. You've got a product, but you also have a quotient. Now this can be a pretty nasty looking problem here. Let's see if we can't help us out just a little bit by eliminating one of those. I'm going to distribute the x to the fourth through this, and so I have 2x. Let's back up and do this correctly. I have x to the fourth minus 2x to the fourth divided by x plus 1. Now I have the difference of two functions, and then I have the quotient over here. So we got to be real careful on how we do this. So we've got the derivative equals, let's take the first one, that's going to be the easiest one. The derivative of that is going to be 4x cubed. Again, to show me some work for the first few attempts at this, it'd be 4 minus 1. Okay, then we're going to have the quotient. And the quotient again is going to be a fraction. You must show me the derivatives as you take them. So we have the denominator times the derivative with respect to x of the numerator, and that's going to be a negative 2x to the fourth, minus the numerator times the derivative with respect to x of the denominator, all of it divided by the denominator squared. So we have from our first term 4x cubed minus, and I'm going to now, let me go back and change just one thing. I don't like this being a negative. I noticed that we already had it as subtraction, so we're just going to take it as 2x to the fourth there. So please go back in your notes and make sure that we're all interpreting this as minus this fraction, and so the numerator of that is just 2x. Okay, so minus this fraction, so I have my x plus 1, and then I have the derivative of 2x to the fourth, which is going to be 8x cubed. I'm just going to write it that way. I'm going to let you do that also. You don't have to do the 4 minus 1. As long as you know how to do that, at this point we can drop that writing of the 4 minus 1. Minus the numerator, 2x to the fourth, times the derivative of this polynomial. Well, the derivative of x, the exponent is 1, the coefficient is 1, so that's 1. And if I have the exponent 1 and subtract 1, that's x to the 0, so that's simply 1, plus, and here's our constant term, 0, divided by x plus 1 quantity squared, equals 4x cubed minus, now this is showing all derivatives that we're going to take right here. This is, we actually take the derivative, so this is where we actually did that. And remember, you now need to show 2 more lines of algebra. So let's see, this would then be 8x to the fourth plus 8x cubed minus 2x to the fourth divided by x plus 1 quantity squared. And let's see, for another line of algebra, I could have 4x cubed minus, let's see, I have 8x to the fourth minus 2x to the fourth. That would be 6x to the fourth minus 8x cubed divided by x plus 1 quantity squared. Well, we might as well go ahead. We can do a few more algebra steps here, and I expect you to take the obvious one. So the obvious one here would be to factor out a 2x cubed, and this would then give 3x minus 4 divided by x plus 1 quantity squared. And I would consider that to be done. Now, is that the answer that we're going to get from the Inspire? Well, let's give it a go and see. Let's go in and add a calculator. And let's go to calculus and let's find a derivative with respect to x of, and we need to go back and remember our original problem. Remember, always put in the original problem. So we need x to the fourth so we have x to the fourth times, so put another set of parentheses, 1 minus, and then we have a fraction, and I believe that is what, 2 divided by x plus 1. Okay, do the answers match? Well, obviously our answer isn't quite the same as that. Okay, let me see if we can show it here. Our answer isn't quite the same as what they have here. But are we wrong? Well, let's check it and see. Go up and capture that value. Use the up arrow, press enter, find your equal sign, and we're going to type in our answer here. So let's see if I can get this to show enough on both of these so I can see it. There we go. 4x cubed minus, and then we need a fraction, and let's see here. Our final answer was down here. Minus 2x cubed times the quantity 3x minus 4 divided by the quantity x plus 1, and we need to make sure we square that. Okay. Now, it looks like what they did was to combine these as one fraction, so chances are that if we did the same thing, we'd have a correct answer, but let's see if in fact. Well, we don't, it doesn't come back as being correct. Sometimes we are correct, and it does this because you see this little reminder, the domain may be, the result might be larger, and that's because we're squaring this. So we need now to go back and just double check our work, maybe do some work to see if in fact we can simplify this. So we'd have 4x cubed times x plus 1 quantity squared minus 2x cubed 3x minus 4, all of it divided by x plus 1 quantity squared. Let's see, we'd have to have 4x cubed times x squared plus 2x plus 1 minus, let's see, this would be 6x to the 4th plus 8x cubed. What we could have done was, well, I guess we can't because we don't have a common fraction here, but at this point we could compare our fraction numerator with what was in our Inspire. Let's see, this is going to be 4x to the 5th plus 8x to the 4th plus 4x minus 6x to the 4th plus 8x cubed, all of it divided by x plus 1 quantity squared. Are we getting even close to the answer that they had? Their answer was 2x cubed plus 2x squared plus x minus 2, divide by that. So are we getting even close to that. Well, let's see. We've got 4x to the 5th. We've got a couple of x to the 4th, so let's make this 2x to the 4th plus 8x cubed plus 4x divided by x plus 1 quantity squared. And I can factor out a 2x. Okay, I can tell right now that there is some error. You probably have found it. I'm going to pause and see if I can find my error, and we'll come back. Okay, I indeed did find my error. You might have picked it up sooner. Back in my work, for whatever reason, we don't know why, I took the plus 8x cubed and made it negative, so it should be plus 8x cubed. Factor that out, be plus 4. I went back in my work here. I went back up and changed my answer that I had before and put a plus there instead of a minus, and I do get my word of true. So it does work, and we are able to use the quotient rule successfully. Again, show me the derivatives, take the derivatives, and then at least 2, and we could have stopped right here because our answer did check. Okay, there's a few of these that for the trig functions, we're not going to prove these. These are, again, some of these that you need to be able to use. I would tab this or somehow remind you yourself, make a little note of what these derivatives are. Derivative tangent is secant squared and so forth. We're then going to just be using these in our work. So here we go, the derivative of this function. Again, it's a product. We need the product rule. You're going to show me all the derivatives. So I have the first factor times the derivative with respect to x of the second factor, plus, because we are multiplying, the second factor times the derivative with respect to x of the first factor. Okay, so then after you show me those, you're going to actually take the derivatives. So we have 2e to the x. Derivative of cosine is negative sine. And then plus cosine x, and we have the derivative of 2e to the x. This is a scalar, and so we're going to end up with 2 times, and the derivative of e to the x is simply e to the x. So we show the derivatives, we take the derivatives, and you owe me 2 more algebra lines. So let's see, this is negative 2e to the x sine x. Plus 2e to the x cosine x, and we can factor out a 2e to the x, and we'd have negative sine x plus cosine x. And again, we can remind ourselves, again, this is a function whose output provides the slope of a line tangent to f of x, in fact, in this point, g of x at a point.